Have you ever wondered how a car's hydraulic brake system works? How is it that I, with just the tap of my foot, can stop a car that weighs 370 pounds plus my own weight? We can actually explain the concept of how this system works using our basic understanding of fluid statics.
Consider this simple hydrostatic system in the diagram here. Now, because the system is confined and height is negligible, pressure throughout the system must be approximately equal. Now, if you look at point 1, where force 1 is applied over an area 1, you must note that force 1 divided by area 1 is equal to the pressure. Equivalently, at point 2, force 2 divided by area 2 is equal to the pressure. Now, if you look at the ratios there, force 1 over A1 is equal to force 2 over A2, you'll note that if area 2 is 3 times larger than area 1, then equivalently, force 2 must be 3 times larger than force 1. Thus, you have the force amplification we were talking about here. Now, as an added bonus, because it's a hydrostatic system, the fluid can travel through any path. You could arrange the tubes however you like and still transmit force from between point 1 and point 2. Now, you might be wondering, how is it that we've conserved energy with this system? It seems like we're getting a huge amount of force out for a relatively small force in, and that's what you got to think about when you're thinking about conservation of energy, is the work done. So work is equal to force times distance. So, say if you move piston 1 with area 1 by some distance, let's say 1 centimeter, and piston 2 with area 2 is 3 times larger, then you'll note that the piston 2 will only move 1/3 of the distance. So if you're still having a little bit of trouble trying to understand hydrostatic force amplification, consider this simple analogy of an asymmetrical teeter-totter in this diagram here. So length 1, if it's 3 times longer than length 2, will mean that you only need to apply 1/3 of the force at force point 1 as the force that's applied at force point 2. And as a result, the force would be amplified for equal lengths, but if you were to move the teeter-totter at point 1 versus point 2, it would move through 3 times the distance. To help me further show you guys this concept, I'm here with Cole Merkel, who's another member of the Queen's Baja team along with me.
Hello.
And so we've got here a hydraulic jack, which we can use to show the same concept of mechanical advantage that will give us a force amplification. So Cole, you can step on the jack here. So I've got a pretty long lever arm here. So each time I pump the lever, I put in a relatively small force over a fairly long distance, which is then translated into the hydraulic system, the hydraulic piston of the jack, which moves only a very small amount, and by effect, I only move Cole a very small amount. And as you can see, it's pretty clear how I can get a force amplification here. Cole is much heavier than the force I'm applying to actually move him, but it's all about force times distance. Now, we can take a lot of these concepts and apply them back to hydrostatics, as we were talking, and we can really get into how it's applied to the Baja vehicle. So, I'm a member of the Queen's Baja SAE design team, which is just one of many very good design teams we have here at Queen's University, wherein you can take information and skills and knowledge that you learn in the class and apply it to an actual real-life scenario, such as constructing a complete drivable car. So, what we're going to talk about here is the actual brake system of the Baja vehicle, and I'll break down roughly what happens for you in the system. So, when you're applying force to the brakes, what you do is you first apply a force to this brake pedal here. The pedal itself has a built-in 6-to-1 force amplification, a mechanical force amplification, just from the force being applied here to the force that gets applied into these two pistons here that are they're referred to as the master cylinders. So the master cylinders contain a large volume of brake fluid, which is an incompressible fluid that we use in brake systems. And when I apply a force to this pedal, I push fluid out of the master cylinders and into these flexible hosings here, which we refer to as brake lines. So fluid is pushed through the master cylinders, through the brake line, and down into the wheel packaging, where we see here this device, which is called a caliper. So, just like in the example we talked about in class, there's actually a piston bore area, it's referred to, on the master cylinder, and there's also a piston here at the caliper. So, to get the force amplification that we're talking about, the area at the master cylinder will be much smaller than the area
of the piston right here in the caliper. So you say if the area is 1/2 or 1/3 the size, you'll get 2 times or 3 times force amplification here at the caliper. So attached to those pistons at the caliper, we have brake pads, which when pushed will articulate and clamp down on this disc here, which is the brake rotor. And then it's a simple matter of friction between the pads and the rotors to stop any motion and prevent the car from moving. So hopefully now after this video, you feel comfortable with understanding how fluid statics concepts can be applied to real life applications.